Hello, once again. Thank you for joining us. This is the Space Nuts Podcast, episode 247. I am your host, Andrew Dunkley. Great to be with you again, and joining me as always is Professor Fred Watson, astronomer at large. Hello, Fred.
Hello, Andrew. How are you doing?
Well, thanks. How was your Easter?
Busy. With I'm right at the pointy end of the children's book, and the last bit is the cartoons, which I'm drawing.
That must be fun.
Because it's absolutely heaps of fun, and I really enjoy it. But they take kind of longer than you expect, so I'm really up against the deadline. But we'll see how I go. I have a bit of an extension from the publisher to the middle of this month to get the cartoons done, and I'm getting there.
Middle of this month, which is a week.
It is actually a week, that's right. Exactly. I might do some, I'll just have to see if I can do some fast talking. I hope nobody from New South Press is listening to this, but we're in good shape. I'm about to send off the text, which I'll hopefully do today, and probably the cartoons for the first 4 chapters, which are the ones that are actually complete.
Terrific. Can't wait. I've got it.
Yeah, what about your Easter, Andrew? How did you
My
go?
boys came up from Sydney. My eldest and my youngest live down there. My middle child, also a boy, lives just down the road from us with the 3 grandchildren, and we all got together, and it's the first time they've all seen each other in 3 years. And it's the first time that my 2 Sydney boys have met their niece, their youngest niece. So that was all very exciting, and it went well. So family barbecue, sitting around the fire pit, although it wasn't really cold enough for a fire pit, but we did the marshmallow thing, and that was a disaster. But it was pretty good fun. It was really nice to just sit back and do nothing and just talk about whatever we felt like talking about at the time. We usually end up having these big discussions about movies. I don't know why, but that seems to be the family topic whenever we get together. Yeah, I've got to talk about something. It's better than talking about politics. Although we do that too. Now,
most people talk about what's wrong with Auntie Mabel, or something like that.
Yeah.
So it's good that you.
We did that too.
Different.
We did that too. And how did you know I had an Auntie Mabel? Now,
there you go.
Coming up in this episode, Fred, we're just going to touch on Ingenuity, the helicopter. The test is about to happen, and they're being super duper careful about this, but who can blame them? They can't send the mechanic out if the wheels fall off. There's also some new data that's come out of examining the Chicxulub Crater. That's that big asteroid impact that polished off the dinosaurs about 66 million years ago. Actually, it's been about a year since we talked about this, so it's 66 million and 1 years ago. There's also been a discovery of one of those elusive intermediate black holes, we think. And we're going to tackle some text questions today. We haven't done any for ages, but we're going to do a couple today, actually 2 double bungers. Andre from the Netherlands has sent us 2 questions, and so has David from Springfield. So we will get into those on this week's episode. But first, Fred, let's go back to Mars and talk about this test flight that's coming up soon for Ingenuity. The news I hear is that they have dropped the helicopter from the belly of the beast, Perseverance, and it is getting ready to be, ramped up, almost literally.
Exactly, that's right. There's a tweet from NASA's Jet Propulsion Laboratory, which I liked. This was at the weekend. I liked very much. It said, Mars helicopter touchdown confirmed. Its 293 million mile or 471 million kilometre journey aboard NASA's Perseverance ended with the final drop of 4 inches, 10 centimetres, from the rover's belly to the surface of Mars today. Next milestone, survive the night. And that's because as of, I think it was Saturday, the Ingenuity helicopter has been now relying on its own power for the heaters that keep the electronics warm, because until then it was taking power from Perseverance itself. Now it's on its own, and so it relies on the batteries, the internal batteries, and the solar panel, which sits on top of the 2 rotor blades. So hopefully that will all keep going well. The heater apparently keeps the inside at about 7 degrees Celsius or 45 degrees Fahrenheit, because the temperature on Mars drops to way below zero. It can be as low as minus 90 Celsius, about 130 minus 130 Fahrenheit. So look, it's I think all is going well as far as I know. They've checked out the solar panels and we haven't heard anything to the contrary. The first flight, now I read somewhere that it was planned for the 8th of April, but the latest is not before the 11th of April. So we still have a few more days to wait. But isn't it going to be fantastic?
Yes.
The first flight's going to be climbing round about 10 feet, 3 meters or so.
Just like Perseverance, which has gone 6 meters.
Yeah. It's obviously gone further now because it's
had to move off.
Drive over the helicopter so it doesn't accidentally back into it.
It's going to be fascinating, Fred, in that the atmosphere being so thin, it takes a lot more effort to get off the ground than it would on Earth, surprisingly. But the thing in their favour is the lesser gravity. So I'm not sure that will counter the thin atmosphere, but it will to a degree, I imagine.
Yeah, I mean, it's really going to be very interesting to see whether it works or not, given the 1% atmospheric pressure on Mars. But look, it's the engineers have done their job. My bet is that it will work just fine.
Yes. Well, everything's gone so well so far. We just got to keep that momentum going. And to get off the ground, they've got to achieve some massive rotational rate, haven't they? It's quite astonishing.
2,400 RPM is the rotor speed. It's pretty fast,
and look,
faster than your average
helicopter. If it doesn't get off the ground, we can wait till Mars is terraformed, turn it upside down, and turn it into a lawnmower. So that's.
You might have a long wait because terraforming Mars is physically impossible because the atmosphere just flies away. Yes,
indeed. All right. So, and I notice a lot of people have been talking about this on the Space Nuts podcast group. So there's a lot of excitement. Everyone's really looking forward to this. And look, why not? I mean, it's never been done before. This is all brand new science in terms of flying an aircraft on another planet. So we can't not be excited about this, I'm sure. But hopefully in the next week or two we'll be able to tell you what happened, because no one else will. No one else will bother. It'll just be us. Now let's move on to our next topic, and we're revisiting an old friend, the asteroid that came down in what is now the Gulf of Mexico and obliterated the planet, not just the dinosaurs. It finished them off. But there's some new research that's come out that suggested that other things happened as a consequence of this impact that probably had a big effect on why the Earth is the way it is today.
Yeah, that's right. This is something that certainly I've never thought about before, but scientists at various institutions think deeply about this kind of thing. One of the effects of the dinosaur-killing asteroid, if I can call it that. We usually call it the Cretaceous Tertiary event.
I like
in
that.
Fact, it's got a slightly different name, but the KT event, when 66 million years ago, when something we think about 15 kilometers across hit the Earth at about 30 kilometers per second and caused not just a big explosion, but all the absolute devastation that you'd expect, including a blanket of ash that would have stopped the solar radiation, probably got a kind of nuclear winter effect, all of that. And so I think, actually, come to think of it, you and I have spoken before about the effects on the fossil record in terms of the microorganisms, because we know the dinosaurs don't appear above that layer of the strata in the Earth's crust, the fossil levels, different fossil levels. So people have analysed other things, not just the traces of the dinosaurs. They've looked at fossils, for example, of leaves and pollen, and leaves tell you something really interesting, because often they've got insect bites in them.
Oh, yeah.
and apparently this is one of the things that they've looked at. Insect bites on fossilized leaves essentially show that insect diversity fell dramatically after the event. As did plant life. In fact, the same is true with the leaves themselves. You get this decline, in fact, by an assumed roughly 45%. That's diversity of plant life. It's not the number of plants, it's the number of species of plants, shot down by 45% after the impact. And the fossil record shows it took about 6 million years to recover to something like it was. But the other really interesting aspect of this work, and it comes from a scientist called Carlos Jaramillo, I think is probably how you pronounce his name, in the Smithsonian Tropical Research Institute in Panama. He says if you return to the day before the asteroid fell, the forests of South America would have been an open canopy with a lot of ferns, many conifers and dinosaurs, of course.
Yes.
The forest we have today is a product of that one event 66 million years ago. And essentially what they're suggesting is that the conifers and the ferns basically disappeared, and they were replaced by essentially flowering plants, but that it actually increased the canopy. The forest canopy is much greater now than it was before. Actually, another comment from one of the other scientists, Ellen Curano, she's at the University of Wyoming. I think the number one lesson here is unpredictability. When you have these major perturbations, they change the rules of the whole ecosystem. And one of the things that they're suggesting is that in the lower levels of the forest, the dinosaurs before the impact were trampling everything down and kind of eating stuff. So the lower levels were much more sparsely, variated, or what's the word for populated by plants, much more sparsely covered. So the dinosaurs had gone, so that changed what was happening to the forest floor. But at the other side of the coin is, and I mentioned the ash that came because of the impact a minute ago, but when that settled on the ground, because it all basically falls out of the atmosphere effectively, they're suggesting that it served as a fertilizer. So you end up with a much more nutrient-rich soil, and you get these fast-growing flowering plants, and they sort of bounce back in a way that some of the other plants don't. Actually, another quote from somebody called Bonnie Jacobs, who's at the Southern Methodist University in Texas. She says, "We love the way it ended up, this incredibly diverse, really structurally complex forest, but right now we should be aware that we're living through a mass extinction caused by humans. Once again, ecosystems are being set on a different path." So there's a lesson in this, that comes back to us from the Cretaceous Tertiary boundary, that events like asteroids can change the whole ecosystem for another 66 million years. And we are kind of mucking around a bit too.
Yeah, what I found interesting was we draw a line where the dinosaurs stop, and then life as we know it starts to begin, I guess. But the other interesting factor that came out of this is that you spoke of the conifers and the ferns that disappeared, but they were replaced by legume trees that produce pods and seeds, and they sort of don't exist prior to this impact. So it changed the planet to a point where you'd have to say it was an extremely dramatic change in the entire ecosystem and development of the planet's life cycles and the types of life that came about. And one wonders what humans might or might not be like had that thing never hit us.
Oh yeah, yeah. We may well not have been here because dinosaurs ruled the earth at that time. They were big and ferocious, and mammals were small creatures that kind of cowered under the what cover they could find on the forest floor.
Yes.
We may be a product, indirectly a product of that event.
And another thing that comes to my mind is, I wonder if there was anything in that asteroid that ended up in the atmosphere after the impact that settled down and perhaps caused certain factors of life to change or alter. I don't know. It's a bit out there.
There is certainly one thing that was in it is what told us it was there at all, and that's the iridium that was present in the asteroid, which is not really found in any great quantity in the Earth's crust, but it's essentially something that you do find in extraterrestrial objects, and it was basically Luis Alvarez and his son, whose name I can never remember. It's terrible. It's
Louis Jr.
Shocking that I can't. Walter
Close.
Walter Alvarez. It's come to me. Yeah, Luis and Walter Alvarez. They were essentially geophysicists, but they discovered this layer of iridium that corresponds to the boundary where between strata that's got dinosaur fossils and strata that hasn't. And that was when they alerted two colleagues of mine in Edinburgh who were working on this at the time. I probably mentioned this before. Bill Napier and Victor Klube were working on the same thing, and they, basically the information was shared. Although in fact Bill and Victor really didn't share in the glory of it all. It was the Alvarez duo that have shared in the glory, because they had a press release very quickly after that.
Yeah, well, fair enough. He who hesitates is lost.
Enough, that's right. Yeah, well, that's right. And of course, we're terribly British in Edinburgh. We were scientists. Actually, I should say we were terribly British in Edinburgh, because that's in Scotland.
Yes.
But yeah, it was an unhappy time for Victor and Bill. I remember it very clearly because I was working with them, not on that topic actually, on other stuff.
Fair enough, but yes, more information coming out of the study into the Chicxulub Crater, and who knows what else we'll discover. But the rainforests as we know them just didn't look anything like that or have the plant life that they have today. They were very, very different indeed. So what else are we going to learn, I wonder? We'll tell you when we find out. This is the Space Nuts podcast with Andrew Dunkley and Fred Watson.
Space Nuts. You've been listening to the Space Nuts podcast. Available at Apple Podcasts, Google Podcasts, Spotify, iHeartRadio, or your favourite podcast player. You can also stream on demand at Bytes.com. This has been another quality podcast production from Bytes.com.